Alright, so we are talking about perpendicular lines. So just let's get straight on what a perpendicular line or two perpendicular lines are. Lines that are perpendicular to each other. Let's see here. Let me just draw like a little part of a coordinate plane here. Um, so if I were to draw, a line that I could draw a line that's perpendicular to that one, you know, like that. Let's make that a different color. Okay, so basically what happens is um, perpendicular lines form a 90-degree angle. That's kind of sloppy, sorry. That's a 90-degree angle. Sorry, let me write it this way. Yeah, that's a little better. Um, okay, so how do the slopes of perpendicular lines relate to each other? Um, the slopes of two perpendicular lines are the negative reciprocals of each other. So if the slope of this line is 3 over 4. I don't know what it is. I don't have anything labeled here, and could be roughly 3 over 4. Then the slope of of this one would be so the reciprocal would be 4 over 3. You just flip it over, and then um, it's a negative reciprocal, so you just flip the sign. So that was positive, so I'd make this negative. If I started with a slope like this and I wanted to make a perpendicular line, the perpendicular line would be the negative reciprocal of that. So reciprocal 3 over negative 4, but then the negative reciprocal, you flip the sign. So instead of this being negative, you make it positive. So the perpendicular line would have a slope of 3/4, which, of course, that's what I start with. So to write the equation for a line that's perpendicular to another line, you need to know its slope so that you can find out the negative reciprocal of it. And then um, if if I want to know what is a line that's perpendicular to the first and go through a certain point, uh, you know, once I have that point, then I can use that to write the full equation for a line that's perpendicular to the first one and goes to that point. So let's look at this first one. Here's the equation for a line. So I want the equation for a line that's perpendicular to this one, and also it's going to go through this point. So my slope of this line is -2. And I know that because this is in the slope-intercept form, y equals mx plus b, where m stands for the slope. So I've got y equals something times x plus something. This particular something is the slope. So the slope is -2. Um, Now I want the negative reciprocal of that to get the slope of my line that's going to be perpendicular. So um, I need to flip it over. Well, first, before I flip it over, it helps me to think of this as -2 over 1, right? -2 divided by 1 is just -2. So the negative reciprocal of that would be 1 over 2. I flip it over, and then I change the sign. So it's negative. The first one's negative, so my negative reciprocal will be that flipped over and then made positive. So I know the slope of my new line is going to be 1/2, and I know that the um, line has to go through this point. For me, the easiest way to write an equation where I've got a slope and a point is the point-slope form, right? So the point-slope form says if I've got a point on the line, which we call x1, y1, it's the x-coordinate, y-coordinate, then it's y minus the y-coordinate of the point on the line equals the slope times x minus the x-coordinate of the point on the line. So I'll just use that. Y minus, now here's the y-coordinate of the point that I need to go through. So y minus 2 equals the slope, which is 1/2 for my perpendicular line, times x minus the x-coordinate of the point that the line goes through. Boom, done. Now, I could, if I need to write this in slope-intercept form, I could write this as y equals 1/2 x plus b. I don't know b yet. I don't know the y-intercept. And then I could use this. I could plug in this x and y to this x and y, and then solve for b, and then rewrite that equation. But I'm not going to do that because I think I don't know. That's a lot of work. That's unnecessary if you just need to write the equation of a line. All right. So there's an equation for a line that's perpendicular to this one, and which goes through this point. All right. So let's try another one. Here I've got a line that's already in point slope form. Alright, so point slope form is y minus the y coordinate of a point on the line equals the slope times x minus the x coordinate of a point on the line. So I know that 4 is the slope of this line based on the structure of the equation. That the thing out here is what the slope is. So to figure out what the slope of the line that's perpendicular to it, of a line that's perpendicular to it, I would take the negative reciprocal of this. So again, since this is a whole number, I want to make it look like a fraction so that I can flip it over easily. So I'm going to pretend that, or I'm going to rewrite 4 as 4 over 1, so that I know that the negative reciprocal will be 1 over 4, and then of course this should be negative, because this is a positive number, so I'm going to flip it over and then make it negative. So I know the slope of my new line, and I know a point that is on that line. So if I know a slope and a point, my first thought is point slope form. So I'm going to do y minus the y coordinate of the point that's on the line equals the slope, which we just figured out was negative 1/4, times x minus the x coordinate of the point that's on the line. Now I'll write this in slope intercept form. Just I don't know. I'm feeling generous all of a sudden. So I could write what I know so far. I want to write something that's y equals mx plus b, y equals some number times x plus some other number. I know what my slope is. It says negative 1/4 x plus b. Now this point has to be on this line, so that means I can plug in this x and y, where I see x and y here in the equation. So y, or in this case 11, equals negative 1/4 x, which in this case is 7, plus b. Now this is going to be a little messy. Now I'm regretting deciding to do this in slope intercept, but you know that happens. So we need to solve for b. So 1/4 or negative 1/4 times 7 is negative 7/4, and then 11 equals negative 7/4 plus b. I want to get b by itself, so I add 7/4 to both sides. Add 7/4. So let me do this over here. 7/4 plus 11. Well, if I'm going to add fractions, I need a common denominator, so it's going to be something fourth. This is like 11 over 1. So to turn that 1 into a 4, I multiply it by 4. That means I should multiply the top by 4 as well, so this will be 44/4. So 7 plus 44 is 51. It's 51/4. And let's see. I don't think I can reduce that. So that's b. I'm just going to leave it as an improper fraction. You know, hopefully that won't bother you. So now I know what b is. I just solved for b. So now I can go back here where I had my sort of partial equation. I can just write it with all its information. So negative 1/4 x plus b, which is 51/4. Let me just try to reduce that a little bit. 51. I don't know. I'm kind of blanking out. 12 3/4. 12.75. Let's just call it 12.75. It's a little nicer, I guess. It's a little easier to imagine where it would be on the y-axis. All right. So why don't you do this last one? This is in standard form. So what I would do first is rearrange this into a form where you can identify the slope. So slope-intercept or point slope. And probably slope-intercept would be easier. Then once you have it rearranged so it looks like y equals mx plus b, you can identify the slope, find the negative reciprocal of that. Then you've got the slope of your new line, your perpendicular line, and you've got a point on that line. So then use the point slope form to write the equation for that line.